Hi you guys, it's Miss Arneson and I'm here at school today recording this video, which is why I have my mask on. But this video is to help you do part 2 of lesson 3 in Science 202, what exactly is Redshift. So in class, I like to give notes about this, but since you guys are online, I'm going to make this video and you can still take notes with what I'm saying. If you are in the class, so let's say that you are here on campus, you can come and ask me for a printed copy of this. It's this notes right here. I'll print it off for you so that you can just add to it and take your notes right directly on this paper. But if you're at home and you don't have that option, you can just take this on a regular lined sheet of paper and I can still grade it for you. Right, let's get started. So I've attached this PowerPoint with all the pictures that have themselves on these notes here, and I'll show you what to add. So Redshift is something that really confuses students, and the reason why is because there's a lot of going on to get to the bottom of what actually it is. So as soon as this loads, it's taking a little while. Here we go. We're going to go over that. It's still taking a little while. Sorry about that. Not sure why it's going slow. Doo-doo-doo. Please stop loading and just be done. Okay, great. All right, what exactly is Redshift? Okay, so on a piece of paper, you want to write what exactly is Redshift so that you know what these notes are titled, and you should probably put today's date and your name at the top so that I can know that it's yours. Okay, first thing we have to do when we're talking about Redshift is do a little review on what light is. And you've probably studied light many times in high school, but there's a few things that are really important for you to know when we're talking about Redshift. Light is going to have a spectrum. And if we are talking about multiple, we call them spectra. So that's just the plural of spectrum. And you can see that when you use a prism, for example, you can separate white light, the visible light that we see, into its component colors, which when you mix them all together in light form, they make white light. Isn't that crazy? You mix all the colors together and you get white when it comes to light. That definitely does not happen with paint. But anyways, the second bullet point that you need to write down is that light is a form of wave energy. And that's a really, really big deal because it's carrying energy. Light is carried by what's called a force carrier. This is the third thing you need to write down. The force carrier is called a photon. And photons can travel through a vacuum. So those are important things to write down. That's just background information. So we haven't gone over what Redshift is yet. Okay, this is so cool. When this was discovered in science, it was done by accident by a guy who was looking through some glass. He was trying to get some perfectly clear glass. No matter what, he kept finding that the spectrum would have these little missing parts. And so this is how spectral lines were discovered. Spectral lines, and you can write this down, are light either emitted, so that would be given off, or absorbed by certain elements. And every element has different spectral lines. So in this picture, you can see that the continuous spectrum is the rainbow from red all the way to violet, but sodium has these parts either missing or emitted, depending on if you're looking at absorbed or put off light. Hydrogen looks like this. Calcium's got a lot more lines, and I'm going to show you why these lines are there on the next slide. Oh, just kidding. First, we're going to learn about the different element spectra. So if we look at these two spectrum, we can see that they're complementary to each other. This is an absorption spectra, so it's showing you where the light is missing, and this would be emission, so this would be the light this element would give off. Can you see this and tell which element it is based on the last picture? Let's go back. So this one has 4 lines. Let's check out if we can figure it out. So sodium has, hydrogen has. Have you figured it out? It's hydrogen. So these are the absorption when it absorbs light and the emission when it emits light or basically reflects light. It's emission spectrum. So make sure you know that those are the two differences between these. The emission spectra are going to be mostly a black bar and the absorption is going to be just with these black lines missing. So that's how you tell the difference. Okay, so here's why this happens. This is a little complicated. So if you're like, I don't get this, that's okay. You can just accept that it's true. So experts that do this spend a lot of time learning it. And a lot of times we think in science, if we don't personally understand it, then it can't be real. But this is some people's job. So like hundreds of scientists have worked on figuring this out. And that's how they come up with this picture right here, which is called a model. So why are these electrons absorbing or emitting energy? Well, it has to do with what happens when a photon is going to bounce and whack into an electron in a certain way. So let's review atoms really quick. Make sure that you write down atoms. Atoms are the basic unit of matter. So basically, if you want to have a gold element, you have to have at least an atom. You have to have nuclei, and you have to have them with electrons going around it, and that is the basic unit of gold or hydrogen or whatever element you're talking about. And atoms have two parts, so that's where these bullet points go. The first part is the nucleus. It's right here, and that contains the protons and the neutrons. The next part is the electron cloud, and everything out here, which is labeled by these lines, all of this space out here is the electron cloud. So basically in the electron cloud, there's almost nothing, okay? There's mostly nothing there, but there are these little electrons that are buzzing around. And energy or electrons fit on these, what do we call them, energy levels, and it's kind of more complicated than just concentric circles, but this is a model, so it helps us understand it on a basic level. When a photon, which remember is the light particle, so that's the force carrier of light, when it hits one of these electrons, sometimes an electron will bounce up to a higher energy state. And when that happens, the photon energy gets absorbed. So that's why there's those missing lines. It's because those photons basically get absorbed and they're missing. So the energy just kind of doesn't disappear, it gets absorbed, but you can't see it anymore. And if it hits it certain right and it jumps down to a lower energy state, then the photon basically gets emitted. And that's why we see those bars of light in the emission spectra. So that's what's happening on an atomic level. It's really hard to understand things on an atomic level because they're so small that you can't imagine them. Okay, that was all background information. And our last piece of background information that we need in order to really understand what's happening with redshift is something called the Doppler effect. And the Doppler effect is related to sound waves. So analogous means that something is the same. So when they're analogs, it means that they're basically doing the same thing. And in this case, sound and light waves are going to be analogous. They're going to act similarly. The difference that you need to know here is that sound waves require a medium like air because sound waves bounce off the air, but light waves do not. They don't require what we call a medium, so they can go through empty space, and that's why the sunlight gets to us because there's empty space between the sun and us. So it's a really big deal that it can go through nothing. But light is different than sound because sound requires a medium. Okay, here's what happens in the Doppler effect, and I know you've heard this before. When there's an ambulance coming towards you, you can probably tell. The way you tell is because the pitch starts getting higher. It's moving towards you, and the sound waves are basically stacking up near you. So it's like, this sounds more like a motorcycle because I'm not going to do the ambulance, but switch to motorcycle. So that motorcycle is coming towards you, and the pitch of the sound is going to increase. Then when it goes past you, let's say the motorcycle has driven by now, it's going to start going, and that's how you know that it's driving away. The same thing happens with light waves. But because of the way that light waves are on the spectrum, which is going to be in our next picture, okay, we have the longer wavelengths on the red side of the visible light and the shorter wavelengths on the blue side. This is called the electromagnetic spectrum. It includes all types of light. You might not have thought about radio waves being light for a really long time, but even the signals that get sent to your cell phones from satellites are a type of light. And there's a bunch of types of light, which we go over in another class. But for this class, we're just focusing right here on the visible light. So when things get redshifted, what it means is that it's moving away from you and the wavelength is stretching out. If something is blue shifted, that would mean that it's stacking up because it's coming towards you, just like the sound does. So if you want to draw this picture basically on your notes, that would be really helpful for you. When the light's coming away from you, when it's going the opposite direction, so here's the object moving away, it's going to get stretched out, and that turns the color a little bit more red. When it's going towards you, it turns the color a little more blue because it's squishing those waves together and making the wavelength shorter. So here's what it's going to look like. Okay, so here's our visible spectrum. An electromagnetic spectrum, EMS, we just write that to stand for electromagnetic spectrum because that's a really big mouthful and we don't want to write that or say that every time. So EMS just means electromagnetic spectrum, all the types of light. This picture is only showing you the light that is on the visible spectrum, so the light that we can see with our eyes. And you can see the wavelength of red is longer than the wavelength of blue. So if the light is blue shifted, it's moving toward you. And if it's red shifted, it's moving away. Here is a shifted hydrogen spectrum. So the middle one is the normal one. This is how it's supposed to look if it's not moving at all. So like if we look at it on Earth. But if we look at it in space, we can tell if it's moving away from us because everything is a little bit redder. And when I say redder, I mean like the purple looks more blue now. Okay, so everything shifts this way, closer to the red side of the spectrum. And if it's blue shifted because it's moving toward you, then everything is moving towards the blue side. So you can actually take an analysis of a star or a galaxy or whatever you're looking at its light, and based on what elements it contains, you can see if the patterns in the light are red shifted or blue shifted, and that's how you can tell if it's moving towards you or away from you. That is exactly what redshift is, and it's a really big deal. Just as a bonus pick, I've added this emission spectra of the sun. And as you can see, there are a lot of different lines here. This, what do you think it means? Like, do you have an idea? Why would we have a whole bunch of lines? It's not just hydrogen. It's a bunch of elements. There's a lot of elements in the sun because the sun is going through nuclear fusion all the time and it's fusing new elements together. So I just wanted to show you this because usually when we look at an object, it contains multiple elements and we have to separate them out and do a whole bunch of analysis, which is why this stuff is hard to understand. Like it's a professional expertise that you have to have in order to do it. All right, guys, hopefully that clears that up.